Now the next question we have about a factor that affects the rate of reaction is the temperature at which our reaction is occurring. So as we know, at higher temperatures, molecules move more quickly and they're more likely to collide with one another and react. Whereas at a cold temperature, the molecules are moving more slowly. It's less likely that they're going to collide and react. So you can think ahead. Do you think a higher temperature would cause a faster reaction rate or a slower reaction rate? We're going to test that. So here I have two containers that are similar to one another. Well, these are identical. If you can find two identical containers, that is great. I'm going to do the same kind of experiment as we just did, but the variable is going to be temperature. So I'm going to measure 50 milliliters of vinegar. We're going to use the concentrated solution each time and change the temperature. So 50 milliliters. And I'm going to place that in one container. There's nothing in this container but vinegar. I'm going to put it in the freezer for about 3 to 5 minutes. Now while that's in the freezer, I'm going to measure 50 milliliters of vinegar again, and I need a little bit more. 50 milliliters of vinegar is what we need. That was about 30. And this one, we're going to make warm using a hot water bath, which is actually something that we commonly use in the lab. So I'm going to add it to this container, and just using the hot water from my faucet, I've been letting it run over here for a few minutes, so it should be warm. I'll just let it run again until it's hot, and then I'll fill up this hot water bath. So what I'm actually using is the cake tin that we use in our percent hydration lab. So if you saved your cake tin from the percent hydration lab, that makes a good hot water bath. And we're going to take our sample of vinegar and set it right inside. Mine is floating, so I have to hold it down. And we're going to let this sit in the hot water bath for 3 minutes. Okay, so we've had our vinegar sitting in its container in a warm water bath for 3 minutes. You want to make sure that the level of your vinegar is below the level of the water in the hot water bath, so that in essence the hot water is making a blanket around your sample and that heat is being transferred into your sample through your container. So now this has been sitting here for 3 minutes, and I'm going to add again a 1/4 teaspoon, just like before, of baking soda. And I'm going to time how long it takes for that baking soda to be completely dissolved. So here we go. I'm adding it to my container with the vinegar in it. And I'll start mixing. I'm holding my container still in the warm water bath. Wow, and the fizzing stopped. Okay. So you can see that reaction time of mine wasted about a second. So I'm going to say this stopped at 16 seconds. I'm going to call it 15 because it took me probably a second to get over there to stop it. But that fizzing stopped very quickly because the vinegar was warm and those molecules were moving around a lot more quickly than they did at room temperature, and they really reacted with the baking soda almost immediately. So at a hot temperature, it took 15 seconds to dissolve all the baking soda, whereas at room temperature, this concentrated solution in the same proportions took 43 seconds. So you can see at a higher temperature, this reaction rate was faster. Now let's look at the cold vinegar. I'm going to get that out of the freezer. So now that's been sitting there for a good 5 minutes. What we're doing is making sure that one sample of vinegar is hot and one sample of vinegar is cold. So we're taking 1 teaspoon again of baking soda. Try to get a sample that's not clumpy so that you can measure it accurately. 1 teaspoon of baking soda, and here I go with my timer. Make sure that you're ready for when you add it. I'm going to start mixing. Now what do you think? If this is cold, it's going to take a longer time or a shorter time to dissolve all the baking soda? Remember, those molecules are not moving around very quickly. Can you hear it fizzing? I'm trying to dissolve all the baking soda. This is another mixing technique. If you have a cup, you can always swirl it. Stir it with the spoon. And you want to make sure that it's all dissolved. What you'll find with this is it may seem like the reaction's ending, but if you stir it and it fizzes more, it's still not quite done. Okay, I'd say that's close enough. So 1 minute and 15 seconds for the cold vinegar. So let's talk about that. Cold vinegar took a whole minute, more than a minute, to dissolve a 1/4 teaspoon of baking soda. Room temperature vinegar in our last experiment took 43 seconds, and hot vinegar took 15 seconds. So you can see what is the effect of temperature on reaction rate. It sped up the reaction. So let's see what you find in your experiment. Make sure you report back to me, sending pictures and sending your data on the data sheet, posting it through Blackboard. And the next thing we're going to be testing is the effect of a catalyst.